Hello students, now in class 11th I will take the topic stationary waves or standing waves. I have taught up to the beats in sound. So now a new topic. Stationary waves or standing waves. These waves always formed in a bound medium. The bound medium means that the medium that has its own definite boundaries. The boundaries may be a rare medium or a denser medium. So either we take the rare medium or the denser medium. The reflection that I have told you earlier also will be taken here also. These waves are formed in bound medium. Bound medium. I give you an example. Suppose we have a string tied between 2 points, then this is the bound medium. Like the wires on the sitar, guitar, etc. Also the organ pipes, these are also the example of the bound medium. These waves are formed when two waves of same amplitude propagate in opposite direction. Direction of each other. So now we define them. When two waves of same amplitude and frequency propagate in a medium opposite to each other. They superpose in such a way that the resultant wave does not appear to move in the medium. When two waves of same amplitude and frequency propagate in a medium opposite to each other, they superpose in such a way that the resultant wave does not appear to move in the medium. It is called stationary or standing wave. Standing wave. These waves do not transfer energy in the medium. The resultant wave contracts and expands between any 2 points in the wave, in the medium. So the medium is divided into many loops. So now I will take the properties of stationary waves. Properties of stationary waves. The first is these waves do not transfer energy in the medium. Second, the medium into many loops. Third, the points where pressure and density of medium are very low, the particles oscillates with maximum amplitude. These are called, these points are called antinodes, denoted by A. Number 4, the points where pressure and density of medium are maximum, are very high. The particles oscillate with minimum or zero amplitude. These points are called nodes. Nodes denoted by N. Number 5, the distance between any two consecutive antinodes and nodes is equal to lambda by 2. This is half of the wavelength. the distance between nearest antinode and node is lambda by 4. So these waves are always found in the bound medium. They have the loops, and I will tell you just by the diagram. This is suppose a wave, and second is like this. Now this is the loop. Here you see the loops. The one wave, now this wave is traveling in this direction, and this wave is being traveled in this direction. So by their superposition, they have same amplitude here. By, and this is now x. This wave is going like this, and this wave is going like this. Then they superpose. You can see that there are these loops. Here this is the node, and this is called the antinode. This is node, this is antinode. This is node, this is antinode. Then node, then antinode, and then node. So we have the points, these points, these points, these points, these points, where the amplitude is 0. Then these are called the nodes, and these are the points where particle oscillate with the maximum amplitude. So these are called the antinodes, A. So now distance between any two, you can take it. Suppose for example, I take it here. This is node, this is antinode, node, antinode, and node. Then what we have, these are the two nodes, and the distance between them, this is equal to lambda by 2. Similarly, we are having these two nodes, then here distance is lambda by 2. If we have this node and this antinode, then this distance will have to be lambda by 4. So this is lambda by 4, like this. So this gives you that there are the loops in the medium because of the stationary waves. The standing waves or the stationary waves, standing means the wave does not move in the medium, so it remains constant at a point. This is why it is called the standing wave. The stationary wave may be longitudinal and transverse. Both. For example, if we have a solid medium, just like a wire stretched between the 2 points, then there will be the transverse wave. And if we have a organ pipe, then just like the violin, there will be the longitudinal waves. So now I take the mathematical treatment of these standing waves. Analytical treatment. Let a wave of amplitude A moves in a bound medium. Moves in a bound medium. Then the equation y equal to a sine 2 pi upon lambda into Vt minus x. This is the wave moving in the positive direction of x-axis. The equation of reflected wave. The equation of reflected wave from rare medium. Now this y equal to a sine 2 pi upon lambda into Bt plus x. This is number 2. This is like this. In the negative direction of x-axis. Lambda is the wavelength, v is the velocity of the wave. Where v equal to velocity of wave. I told you when I told you about the reflection and refraction of the sound waves, that when the wave is reflected from the rear medium, there is no phase change of pi. So they are reflected in the same sense. If there is compression, then it will reflect as a compression. If rarefaction, then it will reflect as a rarefaction. So no phase change. So in that case, only direction will change, but phase will not be changed at all. So now resultant displacement A sine 2 pi upon lambda into Vt minus x plus A sine 2 pi upon lambda into Vt plus x. Now A will take common. Here is sin 2 pi upon lambda bt minus x plus sin 2 pi upon lambda into bt plus x. So this is sin c plus sin d. This is your a into 2 sin c plus d by 2. Add these two terms. So this is now your 2 pi upon lambda into bt minus x plus bt plus x divided by 2 into 2 sin c plus d by 2 into cos c minus d by 2. 2 pi upon lambda c minus d. So c, this is now bt minus x minus bt, and this is your minus x upon 2, like this. We have, so here you see that this minus x and plus x will cancel. Here minus bt and plus bt will cancel. Here the minus 2x, so 2 will cancel, but because of having this cos, this minus sign will be plus. Here 2 bt, so this is now 2 will cancel, so only the bt. This is equal to 2a sin 2 pi upon lambda into bt, and this is your cos 2 pi upon lambda into x. So this is, you can write this 2a cos or 2 pi upon lambda. 2 pi upon lambda into x, and this sin, you can see 2 pi upon lambda is equal to k. So this is k vt, and omega v k omega, this is now omega, this omega term. So this is 2a cos 2 pi upon lambda into x into sin omega t. So what we have, this is equal to y. This is the equation of the resultant wave. So if we have this y is equal to a sin omega t, where k equal to 2 pi upon lambda, and this k upon b is equal to omega. This is the equation of resultant wave. It is the equation of resultant wave. A is the amplitude of the resultant wave. A equal to amplitude of resultant wave. So this A is equal to 2a cos 2 pi upon lambda into x. This is what given to us. So now we have to find the for nodes and antinodes, and you know know that at the antinodes this is maximum amplitude and at the nodes this is equal to 0. So at antinodes what we have? This cos 2 pi upon lambda into x, this is equal to plus minus 1. Because we are having the both amplitude positive and negative. So this 2 pi upon lambda into x, this is equal to your 0, then pi, then 2 pi, then 3 pi, then and so on. Because cos 0 is also equal to 1, so we have this 2 pi upon lambda into x is equal to n lambda, n equal to 0, 1, 2, 3, 4, 5. So you can have from here that this is n pi. So now this pi cancel. So x equal to n into lambda upon 2. Now you put these values. So x is equal to 0. Then this lambda by 2. Then lambda. Then this is 3 lambda by 2. Then 2 lambda. Then this is your 5 lambda by 2 and so on. So n equal to 0, 1, 2, 3, 4, then 5 and so on. So you can see that the distance between any 2 points, either this or this, this or this, this or this is lambda by 2. Hence distance between any 2 consecutive points, this is equal to lambda. So this is what about the antinodes. And at nodes what we have? At nodes this cos 2 pi upon lambda into x, this is equal to 0. So this 2 pi upon lambda into x equal to, this is how much? This is now your pi by 2, 3 pi by 2, 5 pi by 2 and so on. So this is an odd multiple of pi. So we can have this is equal to 2n plus 1 2n minus 1 into pi upon 2. This is equal to 2 pi upon lambda into x. So 2 pi by pi will cancel. So we will have this x equal to 2n plus 1. And after cancelling to this one, it is now lambda by 2. Here n is equal to your 0, 1, 2, 3, 4, 5 and so on. So this is what about the distance. Now you can have this n equal to 0, 1, 2, 3, 4, 5, 6. Then you can find the distance x. So x equal to lambda by 2, then 3 lambda by 2, then 5 lambda by 2, and pi is not lambda by 2, ठीक है, 3 lambda by 2. So this is 0, then lambda by 2, 1, then 3 lambda by 2, 2, then 5 lambda by 2. So similar terms are also here. Lambda by 2, lambda by 2. This come out to be lambda by 4. This is now lambda by 4. Lambda by 4. And so on. So you can find that distance between any two consecutive points is equal to lambda by 2. You can find the difference between these two, any other, then this will come out to be lambda by 2. If we take this one antinode and then one node, this is now 0, this is now your lambda by 4, this is now lambda by 2, then 3 lambda by 4. So clearly the distance between nearest antinode and node, this is equal to lambda by 4. You can find that this is 0, lambda by 4, then lambda by 2 and 3 lambda by 4, then this lambda and then to this one 5 lambda by 4. So you will find this lambda by 4. So this gives you the distance between the nodes and antinodes. So this is what about the standing waves, and I told you that these waves may be two kinds, longitudinal and stationary, and the transverse waves. So you all like, share and subscribe this video. Thank you very much.